Hi everyone and welcome to this probably last video of at least a technical drawing from this document for the CAD/NX practical course. Because I think there will be one or two more videos, but I think they will be on quote unquote old exams. At least one of those. And I'm saying quote unquote because well, as I will also mention in that video, the old exams are not too similar to an exam, at least not the one I'm gonna show. But yeah, that will be the future. And I'm still planning, don't panic, to make a very short video on the the screw. But that's, as I said, not an important thing, I guess. If you have problems or trouble with the rest, then it's all I'd say don't look at that video. And if you have everything down to a fair degree, then also look at that, because I don't want to say it won't be in the exam, as I am not the one who's doing the exams, I'm just a tutor. But I have never seen it so far, that's all I can say. Okay, so let's actually get to the part, because that's a big one, and as every video so far turned out longer than I expected, which is good, I hope, because then you learn more, but to keep it unnecessarily, to keep it from being unnecessarily long, let's go right ahead and look at this bad boy, which is, I would say, the hardest part definitely in the whole document, at least from those that you should do. Bear in mind, we have skipped all of these, which you can try, but I'd say, yeah, they are out of the scope. Definitely, especially that one. Don't mind that one. Don't mind that one. That one you can do. That one you can do. That one you can do, and that one you can skip. So all of these seed parts with rounded parts like these, you don't have the tools for modeling them perfectly. I would say that's not for this course. Of course, afterwards there's still the assembly exercises. If you haven't seen them, do them. And that's the hardest one of those that you should be able to do, definitely. And that's also something, especially this pattern, these round patterns, that I have seen very often in exams, and that are also, of course, relevant for praxis. That's why they are often in exams. So let's look at the 3D representation as always first. We can see it's a gear, kind of a gear. It's called shaft. We have these teeth out here. We have a round base plate. The teeth also are attached to a round cylinder shape thingy with a hole in the middle, though. And this hole isn't simply round, but it has a little cutout here, which also can be seen here somehow. And we have these holes, and we have what we can see here, little cutouts in the bottom that can also be seen from here. And everything comes together in this sketch. Not everything, but most of it. And yeah, that sketch is a little special because it's a section, but I think it might be the first one. No, I think actually there was this tire or something in the beginning where there was something similar, but it's a section which is not in a straight line but angled, and that's something that you have to keep in mind. Why is it angled? Well, if we would have the straight section here, then we would cut through a part of this disc where there's a hole and where there's a tooth, and here we would do the same, but so it would be kind of redundant. And the sole purpose of this cut right here is to be able to show in one sketch how the cross section looks at places where there is this hole and thereby also this cutout in the bottom, where there's this little cutout here, but also in places where there's not that little cutout here, where there's no tooth, and where there is no hole. Okay, so that's the only reason. And that's also important because by now you should see, okay, that's a rotated body, obviously. That will be the easiest way to do it. If we find a cross-section of something that is everywhere, so to say, and what is the biggest common denominator, so to say, of a cross-section, well, that's exactly here, where we have no tooth, no cutout in the bottom, and no hole. These we can do afterwards. We can attach them where they are needed, but the base part, so to say, is in this, and so in the right side, so to say, because of course if we want to rotate, we only need one side of this of this section, and the other side, the left side down here, we can later use for additional information on things like the hole, and also how this cutout looks, for example. Maybe we can draw some other implications, so that's for later. But now we want to focus mainly first on this side, because that cutout right here we can simply rotate. Okay, so that's the first idea, and afterwards we're gonna drill the holes, we're gonna subtract something down here, and we're gonna do the teeth. But first of all, let's do what we already should be pretty used to, which is doing the sketch and then rotating it. So let me start sketching on the ZX plane. As you know, we often, or we always, with a more complicated sketch like that, also want to think about how or where the coordinate system origin should be, the sketch origin. And well, with that part, I'd say it's not that important. One thing that is important, or definitely handy to have, is that the y-axis right here, the vertical axis, will be exactly in the middle, as you know, to be able to rotate it. And then, so we know basically that's that, and where should this axis be? Not that important, I'd say. Why not put it at the lowermost possible part right here? So that means sorry, we need to start with I'd say with that line. Let's go, it's 23 across, so, but here's also the cutout, because we cut through the cutout, keep that in mind. And that's the 3 millimeters. So here we should have exactly 20 millimeters. Half of that is 10, so let's draw that line somewhere, at least in the vicinity of XC10, and then draw it roughly, as I always like to do. I want to be in the profile as always. Now we do a little thing here, go down, go a little bit across, do this angled part like this here. As you can see, I'm just doing a rough sketch, as I'm doing most of the time. Now we're going upward. We need a little chamfered edge here. We need a short part actually, then a little radial element, a straight part down and across. Okay, so that's the shape without any measurements. First of all, let's make this horizontal so we have it out of the way. Let's introduce the 10 right here. Sorry, I have kind of do I want? Yes? Not sure if that was too intelligent, but never mind. And I have kind of overgone where the three, how I know that these are 3. It's because I've done it multiple times, and you can read it somehow. It's 5 across, but that's no help. But how do we know it? Might be with the 10 right here, I guess. I would, if there's a question, just ask in person how you get to that. If not, I guess that shouldn't be the problem. Let's do 28. That's what we have down here. We always have to think in halves for these things. So 14 from the middle. That's easy. Then we have the 10 from here to the here. 10. That should be 2, as you can see right in the middle. Hold on. Where is it? Let me press escape and try again. Yeah, there it is. It's almost good. Then, okay, 150 degrees. Why not? Let's just go step by step around that way, so you always know where I am. So 150, I'm introducing here. Then the next that we see there is the 4 height. Also almost correct already. Nice. Then we have 100 across. Let's see. Yeah, it's completely across. So 50 to the middle, obviously. Then that's 12. Okay, here we're completely off. Is that looks a little bit weird so far, but let's see. That should be 5. That should be, I think we don't know, right? Let me see. Like we have 24 right here. Let's not search for dimensions, but first put in what we see. That's always a tip that I can give you all too. Okay, we have 135, because maybe sometimes it's what I have realized or caught myself doing. You're searching for dimensions for a long time, and they're not there. They're simply not needed. So yeah, just always I suggest starting with what you see, and then if something's still missing, if something's not defined, you have brown lines, then you can still search. Okay, so that's 52. No, but I did it wrong actually. It's from the bottom. So from here. Nice that we have the axis on that line. Makes it a little bit easier, I guess. So that's 52. Okay, still we were way off. Then we have 52 from here to the other side, so half of that, which we already have, but let's still do it here. 36 is in there. Remember, that's why I'm doing it like that. You can always just divide and do stuff like that within NX. 10 between the upper and lower rims of this, on that line is pretty small so right now, so that should be 10, right? Yeah. What else do we have? What we need is that somehow. Then we let's look. Okay, we can look to the other side. Here are some more dimensions. We have a height of 4. That will rule out this problem. So now we have proceeded a little bit more to the searching part of sketching, if you have realized that. And from the top right here to this edge, there's 36. No, 34 it is. Sorry. 34. A height of 3 right here, I can read. Wait. 3. Now a lot turned black. That's nice. We only have missing dimensions here. A radius of 3 I can see. Maybe that will fix it already. Yeah, nice. Our sketch is fully defined. And yeah, without inferring anything, thinking about anything, one dimension at a time, we have done our sketch pretty quickly, I would say. Now let's revolve it. It's already selected, as you can see, and we select our Z-axis because we constructed it nicely, and click on OK. So that's the base part already of our whole thing right here. And I think the next easiest thing to do would be these little holes. We have information on the holes here. 10 is the diameter. And the location. Well, we have an 8 right here, but that's of not too much use because that's in relation to... Yeah, okay, it's in relation to something that we can see in here, because here we have a cut through the cutout, so maybe that can help. Let's try doing a sketch. And why not use the top plane right here? And we need a circle. Obviously it needs to be on this horizontal line right here, because yeah, you can see, I guess I don't have to explain it. We know it's 10 already, and now we just need to find out its distance to here. So let's see. Okay, that's something nice. We see 19 from here, where it goes into a radial element before it's a line. This cutout from below, I hope you can imagine that, because here in the back you see, like if you were looking from here, here's the cut, right, to there, and then you see that as the back, okay, from the side. And here we have the 19, and we know that this line, where the 19 ends from before, is in a distance of 8 to the center point of the circle right here. So the circle should be in a distance of 19 minus 8, 11, to the outer rim, and the outer rim again is 50. So it should be 50 minus 11, right? If I didn't mess that up in my head right now. So let's see. Will you let me grab the middle point? Yeah, you will. Little tip: if you can't grab the middle point, click on the on the arc first, and then you will be able to click on the middle point. And I want that to be 50 minus 11. We said, right? And I think it looks nice. We can't really tell yet because, of course, there's the tooth right here. But I guess it looks, it's if you can see here, it's closer to the outer than to the inner rim, and that should mean that we have calculated it correctly. Sketch is fully defined. Here it is. Now we only need to subtract it. Yeah, you can see it's very long, unnecessarily long. Doesn't make a difference because we're subtracting, but just for demonstration's sake, I'm dragging it a little shorter and click on OK. So we have our first hole right here, and now we need it to be 3 more times, and for that we can use our pattern feature, which lets us either, and I think that was something that we have already done, linearly pattern something. So just let me quickly demonstrate it. If we need a linear pattern, we select the thing that we want to pattern, so our extrude right here. Then we could specify a vector, like for example here, what is it? This axis, whatever it is, y, I guess. And now we can say, okay, in a distance of 10 millimeters, we want 3 maybe, or let's also make distance maybe 15 or something. And now you can see there's this point and this point, and if I click on OK, then it will pattern that 2 times in the direction of the vector that we selected. And if you need to do the same thing, but not only in one but in 2 directions, let me show you what I mean. We select that direction first, like before, And now use direction 2, and we select now, for example, this direction. You can see it now patterns 2 by 3, 3 up in a pitch of 15 millimeters, and 2 across with a pitch of 10. If we like that, it would be 15, 2. And if we would make a 3 right here, now we lost the vector, then you see it would be some more symmetric shape like this. But we don't want this. That was just a quick recap on how to use it linearly. We want circular. By the way, don't bother about the other ones. I have never seen or used them. So circular is the one that we need here, and linear is the only other possibility that you might need for an exam. So these are the important ones. And with circular, we also select the feature that we want to pattern. We specify a vector, and now that's similar to the rotation. The vector around we want to rotate our pattern, which is the same as our, let me click specify vector, which is the z-axis. And now it works the same as the linear one, kind of, just in a circular order. We can now say, okay, we want 4. Now you see it would do 4 like here, like that, and we want a pitch angle of, well, 90 would be the correct choice, as you can see. First one, second one, third one, fourth one, 90 degrees. Let me quickly see. Yeah, okay. So 4, it counts the first one, 2. And of course it was easy for that one now, but and later I think if we think forward, you might realize, okay, that function might also be helpful for our teeth. And here we have 30 degrees. So if you don't want to count them, then you can also look here and choose, for example, count and span, which says I want 4 over the span angle of 360. That would be probably the easiest for now, because we didn't have to say 90 degrees, but we say, okay, it should be equally distributed over the whole circle with 4. And the last option is what we will need later. We say we want a 30 degree angle over the whole 360 degrees, and like that we can do our teeth later. But we are still not at that point. We only need 4, like that. I click OK, and you see it's working. That's good. Now we need to do the same with the cutouts down here. And as seen before, we can see how to do our cutouts here. And I have to admit, the cutouts are a little tricky. Because first of all, I think it's not that trivial to find out where to sketch and how to do them. But in that case, I guess you can kind of imagine which section can I easily find, and in which direction can I extrude it where this section stays the same. And in that case, I hope you understand what I mean if I show it to you. That right here is the section that we need. It's actually just this upper corner. How far it goes down doesn't matter. You will see that later. And then we need to extrude it from here to here and cut it out. That's the idea. It's pretty simple, but I think it can be rather hard to get to that idea if you're doing it the first time. But that's what hopefully at this point you have developed a feeling for, and if not, just practice a little bit more and you will have that feeling until the exam is there, I guess. So let's sketch. We therefore need, for example, this right here. And now we want to draw this right here. So and that's it's a bit tricky, as already said, because we now need to find out, and I'm actually a little bit lost myself right now, what do we have? Well, that everything we have here is not important because it's simply 20 for the extrude later, and the rest of these dimensions was for the circle. So we can forget that. We can also forget that. That's not important, and that is also not important. So we can stay only in this right here. And now, because I actually don't got the idea so far, I will just start, as always, with drawing the profile somewhere. So starting here, let's see, yeah, somewhere around here, we know it's 19, right? So we have that. Oh, sorry. We have that. 19 will be the straight line. And then we have a radius that goes down. I don't know. Let's go somewhere again. And then, of course, we need to cut it, so it has to be closed later. So that's the rough thing. But we still need to say, okay, the radius needs to be 18. And one more thing that's given is the radius needs to, or this arc needs to be tangent to a line that can be a reference line in our case that is angled with 123 degrees to the axis down here. So let's introduce that line. You see the tangency constraint was already created. We make this to a reference immediately so that we don't mess up. And now we need the angle down here of 123. And you see that moved the whole thing. And now we're at a point where we can check what else is movable. We can move it back and forth. We can't move that up and down because we have constrained it to the bottom line. That's good. And we can also not. Okay, if I'm not breaking it, we cannot move something here. Okay. So only in that direction, and that's good because we know the outer rim right here, where the 19 begin, so to say, should be like our outer rim is 50. And now, although I have to admit I was lost myself, you can see with the approach that I'm showing you the whole time, just punching in what you know and then thinking step by step if it's even needed, if it's not already done, like now. We have completely defined our shape, but it still says partially defined. I think that's because we don't have a length right here for our reference line. I think that's a bit stupid that the reference lines need that too for the sketch to be fully defined, but if we just set it, although it doesn't matter, the sketch is now fully defined, and that's what we're looking for. Now you can see we have this in here, and hopefully if we now use our extrude feature, you can see that's already in the direction of what we want, but we actually, and now we need to go back, want it to be 20 millimeters across. And for that, I'm putting the 20 here. No, actually, I'm going to do a symmetric value right here. At end, you saw I did symmetric value. Usually you just have value, but when you do symmetric value, you can type in 10. Now it's only 10. Then you have to type in 20, and then it's making the 20 but symmetric to the point where you're starting. If you don't want to use that, you can also simply do -10 and 10 for start and end, and keep it simple, I guess. Click on OK, and you can see if we look at it from the bottom, it looks exactly like in the technical drawing, I would say. And if we look from it from the side, it looks also exactly like in the technical drawing. And now rinse and repeat our pattern just with that. Selected, circular still selected. We just need just re-specify the vector right here. You see, we see where it will end up. Looks good. Click on OK. That's also in. And now, exactly at the point of 30 minutes, we come to our last element that we need, and that's the teeth. And they are also rather tricky, I would say. Let me show you how I would do it. So of course, the teeth have a pretty easy shape overall. It's just, where can we see it best? Yeah, well, probably you can see it here best. It's just, yeah, like a triangle, but rounded, going smoothly into each other. And that's already one of the complications, that it needs to be smooth. And then you see it looks weird, this double lines and everything. That just means that it's rounded. You can see it here. It's rounded, and that's why it looks like this in the technical drawing. But overall, we just need or want to sketch one of these exactly from here to here in a 30-degree window that we see down here from the top. And that's why we want to draw on the top plane. And first thing with stuff like this is define the window, basically, in what you want to sketch via reference lines. And with window I mean your 30-degree window, which I amazingly hit exactly spot on. Okay, so you can see I've done this a fair amount of times, exactly this part, and still I forgot how to do the bottom part right here, but well, I didn't forget how exactly 30 degrees feel apparently. And they look like this. Convert them to references, and we learned before, if we don't want the sketch to be partially defined, we just give them a random length, the one that we randomly dragged. So let's fix these parameters, then we can forget about it. And now, let's move that out of the way. We have our window in here, in which we want to draw. And now we want to find out where to start. So you can see, and here that's a bit tricky, because you know we want to be on this line. This right here is the outer line. Yeah, this is the outer line of our inner cylinder. Okay, so that's, let me see, we just have to keep that in mind. Okay, and next thing that we need to know is where is the outermost point, because these are basically triangles, you remember, just rounded. And so where's the tip of the triangle, so to say? And we can see that here, because it's 68 across from one tip to another one. So we know from the middle to the tip we are exactly in the middle. So let's do another reference line with 15 degrees in here. This time I didn't nail it at all. And make this a reference, and also give it a dimension for the sake of having everything fully defined later. Drag it out of the way. And now on this line we want a point, which is the tip, so to say. That is in a distance, what is it doing? If right now I would maybe where is it? Enable my dimensions drop down, select linear dimension, select the point as a first object, and sketch origin as a second one. Like that, it's a bit easier, I guess. And we want that to be 68 divided by 2, right? Because that will then be the outermost point right here. And now we also want to know where are the points that are, so to say, on the that will be meeting when we are patterning it around. So what are the points down here on the line, left and right, the other points of the triangle, if you think about it like that. And we know that these are on, as we found out before, on this outer line. Come on, I can't set it. I can't lock it to the layer. Whatever. And this outer line is right here, 52. So it should be 26. Now, please let me fix. It won't let me look at it exactly from the top. Let me see if I can do that from here. Perspective. No. How to do that? I knew how to do it before, but it changed. Because now my F8 key worked. I hope you know that or remember that with F8 you can always do that. And we need 2 more points, as I said, with 26. That's where we stopped before my PC wanted to stop working. We know it's on the line right here, roughly, so I already put it in there. And I give them a distance to the origin of 26. Yeah, okay, no wonder that I nailed that one. We had the reference, but it's not completely accurate. And let's do the same for that point. And that's also 26. Let's see if it's... No, it's not completely accurate. Now it is. Okay, and now we basically have our reference frame, and now we just need to go to the profile function, start from that point, again, like always, do a rough sketch, go up here, do an arc again, which should go through this point though, so let's choose, or let's first come from the other side. That makes it easier probably. From here, up here, and now we need an arc. We choose the arc by 3 points. 1, 2, and 3. Okay, and it looks terrible, but we can fix that rather quickly. Okay, that one is not on the point. Let me redo that. Here you have to pay a lot of attention because now there's so many lines and it's a bit hard to see everything. So try to be exactly on the point. Okay, now it looks ugly. What tells us? What does that tell us? We want tangency constraints, and also I want to decrease the size of these dimensions because it's obnoxious. So tangency right here. I think here it already looks good, but we definitely need a tangency here. No, that's not what we wanted. I suspect, yeah, for example, we have a parallel relation here that we want to delete. Oh, it didn't work. Where is it? I think I deleted it. Okay, looks good. So let's again try the tangency. Okay, let's also try the tangency here. Let's see what it does. This can be a bit of a mess. You have to deal with that. Why is it like that? We still have this dumb parallelity relation right here. And I'm not sure how to remove it in this new NX version. If I'm just clicking it, I'm removing the whole line. But it says click to relax. Okay, so let's relax it. Let's see if that does something actually. And now, no, it stays parallel. Then let's go on and try our relax relations. I'm, by the way, also improvising right now because I'm not sure Okay, that looks better. I think now it's not parallel anymore. So I relaxed the relations, introduced a new one, and that overrode the old. Now, can I... Nah, I can't decrease the radius yet. Then let's just give it, because we know it. And it is... Where does it say it? Here. We have a radius of 3 for that. Okay. Is that a parallelity still, or why does it behave like that? No, looks good. We have a radius of 3 here, and we also know these radii should be 3. Okay. Like that. Come on. And here also 3. Okay. Oh, shit. What did I do? Okay. So far so good. Looks better. Now, what else? What can we do? Because it's still not great, definitely. And now there's something which I might have already shown, and that's knowing how circles or radial elements behave in relation to their center point. Because now we want that this is going exactly tangent, has a tangent to its mirror image if we mirror it along this line. What happens if we pattern it, you know? And that means it should be exactly perpendicular to this line, its end. And you see right now it goes up, but it shouldn't. It should be exactly perpendicular. And that, some of you might know it, some of you might not, works if we drag the point on here. And actually we want to make it coincident. And now if the midpoint is coincident to that line, then that is already established. So let's do the same here. Take that, make it coincident. And now we also need that it's symmetric. We need the midpoint to be on this middle line, obviously. Okay. Now it looks pretty nice to me, I would say. Yeah, there's a tangency. We can see that. There's a tangency. We have the midpoint fixed. We have these points fixed. Yeah. So what can we still move? Okay, we can still move it up and down. So it seems like this midpoint is not coincident to this point. Let me try to grab them. It's again a little bit difficult. Oh yeah, like that. Okay. Yeah, nice. And now it's black. Sketch is fully defined. That's what we need. But in order to be able to extrude it, it needs to be a closed sketch. So I'll just grab an arc. You can also do a straight line, but I feel a little more safe. Arc. Hello. I feel a little more safe with an arc. Now make sure that you have the end point of this arc and the end point of this arc. And now let's do it somehow like this. Okay, where is it? Down here. Let's see what happens if we try to extrude it. We don't need subtract, but we need unite. And we don't want to start at -10, but where do we want to start? Let's see. Okay, it's because we're coming from the bottom, it's 4 from this upper edge, and the upper edge is 12 plus 4. Okay, 12 plus 4 plus 4. 12 plus 8, it's 20. It should be starting at 20. I hope you could follow me here. And then it should be ending. You see, if I do 20, it would be now just where it starts. But we need it to go 25 up, so to 45. And okay. That looks fine to me. Now, let's pattern, I would say. Select a feature, specify the vector. And now, as I told you, it's easiest, I guess, to say 360 degrees. Oh, and I grabbed the wrong vector, as you can see. I grabbed the wrong axis. So again, pattern, select this, select the right vector this time, which is the Z axis. Nice. Go to pitch and span, say we want 30-degree angles over a span of 360 degree. It looks good so far, and if I click on OK, that doesn't look good. Parent features failed to update. That's a new one. Okay. What's the problem here? Let me quickly stop the recording and find out what it is, and then I tell you, because that's a new error. I can't error. I can tell you straight ahead. Okay, I fixed it, and yeah, it's kind of dumb, or kind of, yeah, I'm not sure why NX doesn't work like that, but yeah, it's so one thing I changed, but that's not the problem, is I have inverted the arc right here, but as I said, that's not the problem, because it didn't work like that. You can do it however you want, because it's overlapping anyways, and you won't see the difference after you unite. But the problem was in this extrude right here that we did, so in our tooth extrude, I already had the boolean of unite, and then together with the pattern feature function, I don't know, maybe the unites overlapped or something. It actually makes no sense to me. I can't tell you the reason, but apparently that doesn't work. So well, maybe make sure before you pattern. I mean, with the subtract it worked, so whatever, but maybe in this case, if you run into error like this, you can also try that. Just do it to none first, then the pattern feature works, just as done before. And then we can unite afterwards. So we have this extrude, which we can unite, and then we have the pattern feature, which we can unite with the rest. Wait, unite that and that. Okay, and now we have the whole part. And one last thing that we would have to do is doing the rounded edges. Let's see how that works. How do we have the edge blend right here? It's 1 millimeter. Looks good. Worked as intended. Right here, I also have to tell you that it might be, so that's the finished part basically, but with this edge blending, it's also sometimes a matter of order in which you do the operations. So if you do the edge blend before uniting, for example, it might run into weird errors or afterwards. So if I had received an error now, if it hadn't worked, then I would have deleted the unite, tried to do it on only one, on the separate teeth and everything. That's sometimes a thing you can do, but luckily it seems like I did everything like the program wants, and that's our part. It took us 48 minutes, so that definitely is a part that is too much for the exam, as you might probably suspect, but it's definitely one that has everything I think that you need for the exam. So that's my favorite part actually, because if you can do that without a problem, without my help, if you could do it before without my help, then I think you're safe, definitely. And if you can do it now after my help and practice a bit more, also do all of the other parts in the document that I have listed as important, then you should be fine too. That's definitely a part that sums up, I think, all of the very important functions for the exam and you saw there's no sweep along guide and swept in that one. That's of course the addition that you still need to know, but it's not that common in exams that I know so far. Just a tip without any guarantee. But no, definitely extrude, revolve, unite, subtract, edge blend, chamfer, draft, shell, pattern, mirror, sweep along guide, swept, and whole wouldn't hurt either, I guess. So yeah, as I told you in more detail last time, and as I will tell you also in the exam preparation again. I hope this very lengthy video could help you with this most important part, and we will then see each other in the next video. Bye bye.